Let's learn about discharges to water. Wastewater is water that can no longer be used or reused in the pulp and paper manufacturing process. It is treated on-site or off-site in treatment systems. Once treated, the resulting effluents are, in most cases, discharged to surface waters. Wastewater treatment is designed to remove oxygen-demanding substances as measured by 5-day biochemical oxygen demand, or BOD, solid particles, measured as total suspended solids, or TSS, and all oxygen-demanding substances, including those that are not amenable to biological treatment, otherwise known as chemical oxygen demand, or COD. Finally, wastewater may also contain toxic substances such as chlorinated organic compounds. BOD, TSS, and chlorinated organic releases are regulated in North America. As effluent discharges enter receiving streams, they contribute BOD and COD, which can diminish dissolved oxygen levels if they are not effectively treated. Low dissolved oxygen levels can induce fish kills and reduce reproduction rates in aquatic biota. Discharge of suspended matter, or TSS, may also deplete dissolved oxygen if not effectively removed from effluent. If settleable, suspended matter can blanket the stream bed, damage invertebrate populations, block gravel spawning beds, and, if organic, remove dissolved oxygen from the overlying water column. Suspended matter that does not settle may obstruct light transmission into the water column, impairing aesthetics, as well as diminishing photosynthetic activity and the abundance of food available to fish and aquatic life. For these reasons, wastewater treatment is designed to remove BOD, COD, and TSS to levels that will not cause these effects. Conventional wastewater treatment systems in the pulp and paper industry most often employ two levels of treatment. The first is primary clarification for removal of settleable material, followed by secondary treatment for removal of biodegradable organic matter. This involves biological treatment, the biological conversion of organic matter either to energy required to sustain biomass or to growth and accumulation of additional biological solids. The solids are subsequently separated from the wastewater prior to its discharge. These treatments have a high level of treatment efficiency. There are tertiary treatments that can also be applied to further reduce BOD, COD, and TSS. However, they carry with them the potential for environmental trade-offs that may not justify the additional improvement in effluent quality. Let's talk about BOD, COD, and TSS trade-offs and co-benefits in relation to solid waste. Process measures that reduce the loss of fiber and certain process chemicals reduce solid waste that must be managed through wastewater treatment and improve wastewater treatment performance. Tertiary treatment measures such as chemically assisted clarification tend to improve TSS discharge levels, but require management of large quantities of solid waste. Let's talk about BOD, COD, and TSS trade-offs and co-benefits in relation to energy. Source reductions of BOD, COD, and TSS within the manufacturing process, which capture energy from otherwise lost raw materials, for example by reducing unintended losses of pulping liquor, offer energy savings made all the greater by not having to supply energy to manage them as wastes or wastewater. Although untreated BOD is reduced through using chlorine dioxide-based bleaching, the production of chlorine dioxide uses more energy than producing molecular chlorine for a similar amount of bleaching power. Wastewater and waste management impose a prominent demand for mill electrical energy, and achieving further reductions in BOD and TSS would add to the burden. How is the pulp and paper industry performing when it comes to reducing BOD, COD, and TSS? In the United States, regulatory standards were adopted in 1977, which required the installation of biological wastewater treatment. Since then, there has been significant improvement in effluent and receiving environment quality. These standards were derived on the basis of the average of the best existing performance by well-operated plants within each production category. Deliberations involved consideration of the cost-effectiveness of alternative treatment practices, as well as a balancing of numerous engineering factors and non-water quality related environmental effects, including energy trade-offs, weighed against additional incremental improvement in effluent quality. Since then, the U.S. Environmental Protection Agency has twice reviewed these initial standards for BOD and TSS with little change, a judgment based upon cost versus effluent reduction benefits. Conventional wastewater treatment practices remain the workhorse in reducing BOD and TSS discharges to receiving waters. To learn more about this subject, click on the links on this website.